off and you stepped out? Priorities, Explorer. But I blame myself. You need to see a lot more data at the same time than what 4 characters will allow, and Diowinna is not going to fly. The problem is, again, power. If we shrunk LEDs down, they would use less and less power, meaning we could use more and more small LEDs. Good news, Explorer. The hero scientists have done just that. They placed a whole bunch of LEDs on the breadboard, threw it in a hot wash with their underwear. What do you know? They got an organic LED screen. And shredded their underwear. But that's an issue for another mission. Today's task will involve having the screen display a simple message. Hello, world. An age-old greeting used by programmers across the galaxies. It's not just a test. It's a symbol of the communication we're about to establish with our spacecraft that will ultimately be our ticket back home. Remember, while these may seem like simple tests, they hold vital importance for us. These checks and validations will form the basis of our ability to navigate our way back once we burst forth from this planet's atmosphere. So, Explorer, shall we dive into the wonderful world of user interfaces? Buckle up. It's going to be an enlightening ride. All right, Explorer, let's start with understanding our screen's display pins. Take a look. There are some pretty obscure TLAs here, but here's what they mean and do. GND is ground. VCC is power. Duh. SDA is serial data and sends information or data over the serial line using the I2C protocol. I do want to call out that a serial clock isn't something that wakes you up in the morning. It's a signal that keeps the data here from getting out of step or out of sync, like traffic lights at an intersection or drummers at band practice, usually, if they're good. I mean, some of them just sound like you've dropped a bag of marbles on a water cooler. You're not a drummer, are you? Now let's talk about protocols. In the world of electronic devices, a protocol is a set of rules or procedures for transmitting data between devices. Think of it like a common language that allows devices to understand each other. 2 common protocols are I2C, which stands for Inter-Integrated Circuit, and SPI, which stands for Serial Peripheral Interface. Both are used for communication between devices, but they do have their differences. I2C, like our display, uses just 2 wires, one carrying a sync signal, the other carrying the data. A great system for simple components to talk to each other. SPI uses 4 wires, and we're not using it, so take a hike. No, it's important, but right now, I2C will do just nicely. Our screen uses the I2C protocol, simple and versatile, a multi-tool protocol. All right, Explorer, let's get our hands on the necessary library and put our OLED display through its paces. First things first, head over to inventor.io/libraries and download the U8G2LIB library. This library is going to be our faithful ally when dealing with our OLED display. Once downloaded, let's get it installed into our IDE. Here's how to do that. Click on Sketch in the menu. Then, click Include Library. Next, click Add Zip Library. Then, simply locate and select the downloaded file, which should be this one. Terrific! Now our library is all set up and ready to go. Now that we have our library installed, it's time for a quick test to ensure our OLED display survived the crash unscathed. What better way to do this than the classic Hello World check? Thankfully, our new library makes this easy with a handy function called drawstring, which looks like this. A string is a collection of letters and numbers like a word, sentence, or even this train wreck of a term. Seriously, that might be my new password. This function will let us display the phrase Hello World, or any other string for that matter, on our OLED screen. A successful display of this message will confirm that our OLED is in working condition and is ready to navigate us back home. And with that, it looks like you're ready for the next phase of today's mission. We'll turn to the instructional material that I've gathered, cached on the computer. It is also readily available in your mission resources. I know I'm the best.
Hello everybody and welcome back to day 21 of the 30 Days Lost in Space Adventure Kit code explanations. First of all, I'd like to congratulate you guys on getting out of the water. From what it looks like here, you guys are currently doing very good. It looks like the solar panels are working at full capacity and the flotation devices and all these other calibrations are done correctly. So good on you guys. It looks like you guys are one step closer to making it back to the mothership. But before we do that, we do need to take a moment to set up the GPS system, which is obviously not working correctly. And in order to do that, we're going to need to set up a new piece of hardware to make this display on your control panel working. In fact, it's probably the most important display on your entire control panel. This is the 128 by 64 OLED display, and this has a total of, you can think of it as 8,128 tiny little LEDs if you consider each pixel to be an individual LED. Now, I'm sure you've noticed we don't have 8,128 pins on our hero board, so there's no way we could ever do that. And plus, these pins, or pixels I suppose, are substantially lower power as well for the little tiny display. But do not worry. The people back in the 2020s were very clever and came up with a good solution to that problem of not having that many pins. And that is what this display is. So instead of having one pin for every LED, our hero will use 2 pins to send and receive messages with our OLED display, and then we'll tell the display which pixels we want to light up using a special language, or technically it's the protocol I2C, similar to SQL, or some people call it SQL. Some people also might call this I2C, but it technically is I2C. The hero board uses pins A4 and A5 for I2C communications. So we will wire those 2 pins to our display along with power and ground, giving us 4 necessary wire connections for displaying messages or pictures on our new display. Starting at the very top of our code, we have what we always have, the include Arduino.h. We don't really need to worry about this. We're using the Arduino IDE, so this is going to be automatically included anyway in our use case. Going down a little bit lower, we now have a new library that is required in order to get this display working. You will not be able to compile this unless you have this library installed. If you do not already have this library installed, just like always, inventor.io/libraries. Once the page loads, you will be able to scroll down and you'll be able to find the Adventure Kit 30 Days in Space required libraries. Make sure that when you go here, you select the U8G2lib library, and then once you have that downloaded, you should be able to go to Sketch, Include Library, Add Zip Libraries, and make sure you include that in the one after you've included it. It should show up down in the Contributed Library section down below. Now, this U8G2lib library supports many different types of displays. It does this by having a constructor for each display that it supports. That means that our display that we're using is just one of many different types of displays that this could possibly support. Our specific display that we're using is this really long complicated name you see here. This is the very specific OLED that we're using, the U8G2_SH1106 blah 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 I2C. But don't worry, just copy and paste that one. I will give you 100% leeway to just copy and paste this whole piece of stuff here. And we're just going to call it, for simplistic reasons, we're just going to call it Lander Display. Because that's a lot easier than saying this. Once we've used the library to define our Lander Display, we're going to go and we're going to be able to use that later on in our code. Here we are in setup, where we're going to be talking of the serial baud rate of 9600, delay by a second, and then we're going to begin. And begin essentially says, okay, set analog pin A4 and A5 as the pins that we'll be using to communicate with our display, blah, blah, blah. Similar stuff that we do with pin mode in regular setup, this just calls it here inside of the library. So when we say .begin, we're just doing the typical pin mode setup and just initializing everything that's needed for our display in here. Next, we're going to select a font for our character to display. The library supports hundreds of different fonts, but in our case, we're just going to choose this one here. You can change this if you really want to something else. If you go to this GitHub link and you want to change it to something else, you totally can, and it will still probably work just fine. We chose this because we thought this was a nice, suitable font from the list on here. Now, this is how you would set the rotation if you want it to be upside up. And by upside up, I mean where you're holding it and the pins are supposed to be on the top, and that should be like where you're looking at it from. But let's just say you have it set up on a contraption where it doesn't make sense to have it orientated that way. You can actually rotate it 100% upside down, essentially flipping whatever's on the screen 180 degrees by uncommenting this line here. If you set the display rotation by R2, which basically says turn it 2 times, 180 degrees, you can technically turn the text 100% upside down if you wanted to. I'm keeping this commented out because it's not necessary for what we're doing here. After setup is completed, we will hop down to our wonderful, wonderful little loop. Now, one thing you have to be careful about, depending on which font you're going to be using, is each font might be slightly different. So the maximum height that you can use for specific fonts that you can choose from, for example, is a little bit different. So we want to save what our maximum font height will ever be in a variable called font height. And we can actually grab that really, really easily because guess what? There's a function included in that library called getMaxCharHeight. This is going to be taking the maximum character height from the library that we defined up here, and we're going to be taking it and putting it into this byte font height. Next, in the loop, we're going to take the lander display and we're going to clear the buffer. This is essentially just going to clear the internal memory, and this is going to make it so that there's nothing to display on the display. We're going to basically clear what's on the display. Next, we're going to have another function. Again, a lot of functions from this library. This is almost like a library explanation video, more than it is an actual code explanation. It's kind of 50-50. The next function that we're going to be talking about is the set font position top. And the reason why this is important is because even though we're only going to be displaying text in this lesson, we want it to display hello world or something similar to make sure that we have it connected correctly. But even though we're only going to be displaying text, the library has a set cursor function to locate the first character to be displayed. And by default, the cursor position is set to the bit at the lower left of the first character. But here, we want this to be set to the upper left of the first character, which makes it easier to position our first line of text on our display. But here's the issue. If you want to tell us to start at 0, 0, which is going to be the very corner, and we want to say exploration lander, right? What's that going to do? We're going to start displaying exploration lander because we're starting right here at the bottom. Do you see what the issue is? We're not in the display. We're currently displaying this off screen. This isn't even going to show up. So the issue is that if you don't set it at the top, because it's by default bottom, you want it to be this. By doing it at this point, which is the very top of it, and we'll actually be displaying it on the bottom. By setting the position to the top, we're going to make it so that any fonts that we use going forward will be starting at the very top part of it. So that at least if we're starting at the default to 0, 0, we won't have the issue of it not showing up. It'll show up on screen. So here we're starting at centered string. So we're taking the total width, and that just basically takes the whole width, 128, and finds out where the center point is for where you want your string to be. And we're just going to display exploration lander. Now, if we want our hello world message to go on line 2, instead of starting at 0, we can start at font height, which is something that we were able to grab here. So let's just say that this E, maybe this is the biggest letter that we're going to have. Let's just say this E is a total of, I don't know, let's just say it's like 15 pixels. Then it's going to save this in here because it knows that our biggest one is 15. And it's going to put that in here so that we start at least one down below that E so we don't have any overlapping text. So this exploration lander hello world is going to remain statically on screen at all times. It's not going to be taken off. It's not going to blink. The only thing we want to have blink to show how this could work is we're going to have the message stand by. blink. And we want standby to blink on and off and on and off and show up and go away and show up and go away and show up and go away. And the way we're going to do this is we're going to have it go where we have a Boolean. And every time we go through the loop, since this is static, it's going to remember that last time it was true, so this time it's going to be false. Does that make any sense? Or last time it was false, so this time it's going to be true. That's how this works. So static basically means that next time we go through the loop, it'll remember what it was last time. So let's just say we want it to blink on in this execution through the loop. Well, I want it to look pretty, so what this is doing here is it's going to center both horizontally and vertically in the remaining space that we have. So the centered Y position is going to be getting the font height, finding out what was taken up by this. And the reason we have a calculation for this is because while we could use variables that tell us exactly what to use, we could hard code it. But if you decided, hey, I want to use a different font, and that font has different values than the font we're using, that's going to make it not centered anymore. So the reason we have this nice big calculation is because that also gives you the option to choose what font you want. So we can take whatever font you had, multiply it by 2, because we have obviously 2 of that same font height. And then we can take the LambdaDisplay.getDisplayHeight, and we can subtract this font height times 2, divided by 2. Big, meaty calculation. But basically, it just tells us where the center point is of the Y position. It's actually not as crazy as you might think it is. And then, once Lambda displayed, we can get the font center position. And we can say standby, given whatever font we have, we're going to center that. And then we're just going to blink on standby. Now, assuming that we have now gone through here, we're then going to say the following. We want it to switch every single time, right? So we have this cool logical not statement here. I'm sure you've seen the if statements before, where they're like if something double equals 12, right? Or if something double equals, like true. What this is this is saying not. The exclamation point is essentially the logical not negator. So if you say, one way you can write this is if blink on long-handed form of writing this is if blink underscore on is double equal to true. And another way you can write this is if blink on is not equal to false. This is a lot more stupid to read at though than just having that. So, but you could think of this not equal to false is essentially the exact same thing as saying equal to true. Because what else could it be? It's Boolean, it's only one or the other. In this case, we're taking whatever blink on is, right? In this case, blink on at this time through the loop could be anything. It could be true, it could be false. But we want it to switch every single time. So we're going to set blink on to be not blink on, which sounds really confusing. But essentially, we're just going to be setting it to be, if it's true this time through, we want to change it to false. And then next time it goes through the loop, it'll be false. And if it's false right now, we want it to be true. So by adding the not negator, the negation to it, we're just going to swap it to whatever the other value is. And since they're Booleans, this is really easy to understand. This wouldn't work very well if this was something like an integer, obviously, but since it's Booleans, it actually works pretty good because there's only 2 states it can be in. Next, we're going to take the Lambda display and we're going to send that buffer. We've accumulated the entire buffer now. We've made the exploration lander, hello world, and then we got determined, are we going to put on the standby or are we not going to put on the standby? I don't know. But whatever it is in this version of the loop, it's either one or the other, either whether this was true or false or not. We're going to send that buffer to the display and delay by half a second for a little tiny blink effect. Next time we go through the loop, we'll do the exact same thing, but it'll do the opposite. For standby at least, and it will either turn it on or off. This is obviously the function we use to calculate the centered string. But that's about it for day 21. That should be all the code explanation. I look forward to seeing you guys tomorrow.
Welcome to the Day 21 wiring example video. As we make preparations for our liftoff, we need to learn to use a new piece of hardware, the 128 by 64 pixel OLED display panel. Today's task is designed to test its basic wiring and function before we call on it later for more complicated operations. You'll notice that in order to keep things clean and easy to follow, we've temporarily removed all the unneeded components and wires from the breadboard and tucked them out of the way so that we can focus today on the connections to our new display. As you have learned by now, the OLED display uses the I2C protocol to communicate with the Hero and only requires 4 wires to do the job. The first 2, on the left here, are simply the ground and VCC 5-volt power connections, which are connected by our traditional black and red wires, here and here, to the corresponding pins on the Hero. The 2 remaining pins are the I2C clock and data lines, which the Hero accesses through analog pins A5 and A4 respectively. In our setup, we have a green wire right here connecting the clock pin on the display to pin A5 on the Hero. And we have a blue wire right here going from the data pin to Hero pin A4. You, of course, can use any colors you like if you find those either convenient or clearer. Our test sketch today deals only with the display of text, although soon we'll also be using it for graphics. We'll use some of the display library functions to print a title and a hello world message on the screen. And then finally, we'll use some delays and looping to blink a standby message on and off, just to further test our ability to control the display. That's all, so let's just go ahead now and give it a try. So going to the IDE and loading the sketch. In a few moments, we should see something appear on our OLED display. There we go. So there's our title, our hello world, and our blinking standby message. So it appears that everything in our sketch is functioning as expected. And so that is pretty much all for today's test. Look it over and make sure you understand all the steps. And next time, we'll keep the same wiring test setup that we have here, but we'll run it through its paces on some non-text tasks. So we will see you then.
Oh, what a great day, Explorer. We've achieved our mission today thanks to your steadfast determination and concentration. The OLED display is all set up and is working seamlessly with our ship's control panel. This is a massive leap towards getting us off this aquatic expanse and back into the familiar emptiness of space. Tomorrow, we'll delve deeper into the newly installed graphics library. We'll harness the power of code and fully explore the capabilities of our OLED display. I am as excited as my programming allows to see the myriad of images and data we can display on this little device. So, take a well-deserved break and rest up for the next exciting chapter. The stars will keep us company tonight. Good night, Explorer.